Hi physics class, I want to do number 5 here on the friction assignment. Okay, so a person wants to drag this sled up a hill. We got 30-degree angle, classic. We got a coefficient for kinetic friction. We have to calculate the force the snowmobile applies on the sled, so an applied force. Okay, if we're talking about a free body diagram, which obviously we are, it's going to look something like this. Here's my sled. Okay. We got FG pulling it straight down, break that into its components, parallel and perpendicular. Okay, this will be the applied force we're trying to find. Okay, so that leads to a snowmobile pulling it up. Of course, we have a normal force. Okay, if we're pulling this thing up the hill, friction will be down the hill. Okay, we've done similar problems like this, but they didn't involve a coefficient of friction, so this one will just be a little more math heavy than our previous examples. Alright, so I hope what we can talk about right now is just that the net force, which will be up the hill, how it combines, it's going to be the applied force, subtract the forces down the hill, which will be parallel and friction. We have the mass and the acceleration, so we can actually calculate this right away, we might as well. Okay, that looks good. So that's the net force up the hill. We are going to need the parallel force. So let's just get that quickly and then we can focus on friction, which will be the trickier parts. Okay. Alright, so I get 171.7 newtons for the parallel force. Let's find friction now. So that's going to be mu times the normal force. Mu is here, so we'll need to find this normal force. But like in a lot of questions, the normal force is just going to be equal to the perpendicular force. Okay, so the perpendicular force is into the ramp, and the normal force pushes back onto the sled, and they have to combine at 0 because this sled certainly isn't going to accelerate in either of these directions. Okay, so the normal force will equal the perpendicular force. Okay, so we know that the perpendicular force is mg cos. So let's find friction here. Okay, so I get 11.9 newtons. Now we can pull it all together. Okay, so these are the three important forces. The net, which is up the ramp, and then these guys are down the ramp. So the way they all combine, I'll have to do it at the top here. We discussed this. The net force up the ramp will be the forces up the ramp, subtract the forces down the ramp. The only force up the ramp is this applied force, which is what we're trying to find. So now subtract friction and parallel. Okay, once we solve this, we'll have our answer. Because we have 3 of these forces, the net, friction, and parallel, we'll be able to solve that for the applied force. So let me just show you that. Okay. I'm just going to add this sum to the 87.5 and we'll be good. Okay, so the snowmobile is pulling on the sled with a force of 271 newtons up the ramp, which is clear from the free body diagram, so I don't need to see it here. Okay, I'm hoping you're getting really good at these free body diagrams and that they help you solve the problem. All right, I hope this helps. Good luck out there.